discussed that if we have some vector, these are the x and y axis. If we have some vector, let's say this is A, so it will have two components. One would be the horizontal component AX, and this would be A cos theta, because this is theta. So whatever side is making this angle theta, because hypotenuse will always be fixed, right? So whatever side is making the theta, that is A cos theta, and then perpendicular to that, this is A sin theta. So this is A sin theta, and this is also A sin theta, right? So this is A sin theta, this is A sin theta. So this was the thing that we have discussed in resolution of vectors, right?
Yes, sir.
Okay, so now let us get back and let us understand the diagram of the electric field due to dipole at the equatorial point. So let us revise this diagram again, right? Let us revise that. So yeah, let me revise this diagram again. Okay, so we have this. So let us draw the diagram. So this is the diagram, right? And we have two charges placed at these 2 points, this one and this one. So this is minus q and this is plus q, right? And now what we do is that we make a perpendicular to this thing, right? So we draw a perpendicular, which is this thing. Yeah. So this is the perpendicular that we draw, right? And then we have this distance, which is A, and this distance, which is E. And this is the distance, which is R, right?
Yes,
And
yes.
now we want to find out the electric field. We want to find out the electric field at this point. So at this point, we want to find out the electric field. Let's say that this is A point, this is B point, this is, let's say, some P point. So we want to find out electric field at P, right? And let's say, so what is this distance? What is this distance? What is this distance? What would be that? What is this distance? This is hypotenuse, right? This is angle theta. This is angle theta. And this is hypotenuse. This is R, this is A. So what would be this distance? This is hypotenuse, right? What would be that? This is A, this is R. So this is hypotenuse. What would be that? We know that perpendicular. Yes. Yes, please tell me. So this would be the hypotenuse, right?
Okay.
So this is root of R square plus A square. So this is root of R square plus A square. This is root of r square plus a square. Right.
Yes, sir.
And we have discussed that the electric field will have two contribution, right? Electric field will have two contribution. One would be due to this charge, one would be due to this charge. So let's say that from this one and this one, the electric field is EBP, right? And what would be that? That would be simply KQ divided by this distance, which is, let's say, x square. So this would be KQ divided by x is root of r square plus a square and then square. So this root will cancel. And this would be simply KQ divided by r square plus a square. This is EBP. So the electric field due to this charge. Now if I calculate electric field due to a charge, so this would be again KQ by x square, and this would be again KQ by r square plus a square. So you see that the magnitude of electric field, right? Magnitude is same. That is EBP and EAP. Both are equal. Both are equal, right?
Yes, sir.
And we see that their directions are different. Their directions are different, then we have to use. So the total electric field will be vector sum, not the simple sum. This would be vector sum, right? Superposition principle. So now we have to find out what is the direction of all these electric fields. We know that both the electric fields are same, right? So now let us find out the direction of this thing. This is positive. This one is positive. So the electric field would be in this direction, away from it. This is E, right? I'm writing E because this has the same magnitude as all these things. So I'm writing it E. This is the electric field, right? Now, due to this minus Q, the electric field is what? That is towards its direction. This is also E, right?
Yes, sir.
And now if I make the horizontal, so if I make the horizontal, this is theta, so this is parallel line. This one is parallel line. So this would be again theta, right? This is theta, so this would be theta. And this one, right? So this one is how much? This is theta, so this one would also be theta. And this is theta, so this one would also be theta. Corresponding angles. This one is also theta, right?
Yes, sir.
So now we will draw a vertical. We will draw a vertical in here. And then we will write it in components. So this is the vertical. And this is the vertical. So you see that this electric field, this upper one, this one will have two components. One would be this one, which is, what would be this component? This is making an angle theta with the horizontal. So what would be this component? Due to this E, what would be this component? What would be this component due to this E? We have just discussed resolution. Whatever the angle theta is making, so this would be E cos theta. Clear?
Oh, yes, sir.
This is the vector, right? This is the vector. It is making theta angle. So this component is E cos theta. This component is what? What is this component? Perpendicular one. Vertical. E sin theta. Good. So this is E sin theta. So this is E sine theta, this is E cos theta. So now this part we have resolved. Now the other electric field. What is the other electric field? This one. This one is making this angle theta. So this would be what? What would be this component of a green electric field? What would be this component?
So which one can you?
So this is the electric field, right? And we are resolving this one. Earlier we resolved the red one. Earlier we
Yes.
resolved the red one, that was this theta. So this was E cos theta, this was sine theta. Now we are resolving this green one. Green one is making this angle theta. So what would be this component? This is the vector, right? This is vector E. And these are the two components. What would be this one? What would be this one? This would be E cos theta and this would be E sine theta. Whatever side is making the angle, that is cos theta. So this would be E cos theta. And this would be E sine theta. If you understand this diagram, then all the question would become simple. So do you understand this diagram? Or should I repeat this one? Because this is the most important diagram. If you understand this diagram, then you can do all these questions very simply, right? But if you don't understand, then it would be difficult. So, did you understand this thing?
I think I understood, but
Yeah, if you
Got
want me
down.
to repeat, if you want me to repeat, then I will repeat it again, right? So, no need to think that, if you have not understood it pretty well, then please tell. I will repeat this thing again.
sure, so you can repeat.
Good, good. So that is the thing that I want to have from you, right? So whenever you don't understand a thing, please tell me, and we will repeat it many a times, right?
Yes, sir.
So let us start from the beginning, right? Let us start from the beginning. That if we have this thing, whenever we have this vector which is A, this is making an angle theta. So this part would be horizontal part. This is A cos theta. This is the vertical part, which is A sine theta. So is this part clear?
Yes, sir.
And now let us erase everything. Like we'll use this thing later, but yeah. So we will now let us label all these things, and then we will come to the what happened. Yeah. So how do I erase this green one? This green one is there, right? Yeah. So let's. Okay, let me make the diagram. Let us erase this. Okay, so what do we have? We have two charges, minus Q and then plus Q. These are the two charges that I have, right?
Yes, sir.
And I want to calculate the electric field at the perpendicular bisector of this thing. And what is that? So this is the perpendicular bisector, right?
Yes, sir.
I want to calculate the electric field at this P point. This total distance is 2A, so half distance is A, half distance is A. And this distance from here to here, this distance is R. So I know that this would be the hypotenuse. Right, so this would be the hypotenuse H, this would be the hypotenuse H. And what would be the hypotenuse? Hypotenuse is simply root of perpendicular square plus base square. What is perpendicular? Perpendicular is R, base is A. So this is the hypotenuse, right?
Yes, sir.
And how many contributions of electric field would be there? At this point, there would be two contributions. One would be due to this one. The other one would be due to this one. right? So there are two contributions. What would be the magnitude? Magnitude of the electric field would be, let's say that this is A point, this is B point, and this is P point. So magnitude of electric field due to A. This would be KQ by H square, right? Because this is
Yes.
the separation between them. And this is also equal to EB. EB is also KQ because charge is Q, and then separation is H square. So EA and EB, they are equal, and I write it E. Right.
Yes.
Now I have to figure out what is the direction. What is the direction of all those electric fields? So this is theta, right? This is theta, and due to A, this is negative charge. This is negative charge, so electric field would be attractive towards this side. Clear?
Yes, sir.
So this is E. Due to this plus Q charge, the electric field would be repulsive. So that would be in this direction. Right. Both are E because the magnitudes are same. That is why I have written E. So this should be EA, this should be EB. But both are same. Let me write it. Both are same. So yeah. So no need to write it EA and EB. So is this part clear?
Yes, sir.
Now we have to figure out what is the direction of all these things. So we will draw a parallel line in here. We will draw a parallel line here. So this one is parallel to AB. This theta and this theta, they are alternating interior angle. This theta and this theta, they are corresponding angles. So is this part clear to you?
Yes, sir.
Up to this point, any confusion, any doubt up to this point?
No, sir.
Okay, now we have to write all the axes. So we will write the axis as this one and this one. So these are the X and Y. So this is X axis, this is Y axis. Now you see that this is making an angle theta. This is E, this is making an angle theta. So this would be E cos theta.
Yes,
And this
sir.
would be E sin theta. Clear?
Yes, sir.
So we have resolved this electric field. This electric field we have resolved. Now let us come to this blue one. Blue one is making this angle theta. So this would be what? This would be what component? What would be this component? This is theta. Whatever side is making the angle theta, so that is the what? That is cos component.
Yes, sir. Sorry. It's cost.
So this would be E cos theta, right? Again, because this is making an angle theta. And then
Yes, sir.
perpendicular one. This one is perpendicular. So this is E sin theta. So now you tell me which one is cancelling, which one is adding up, which one is in the different direction, which one is adding up.
E sin theta.
E sin theta is cancelling or adding up? What is that?
It's adding.
Both are in different direction. One is pulling it away, the other one is pulling it the other direction. So they are in different direction. They will cancel each other out.
Yes, sir.
So we will write that E sin theta are in opposite direction. So they will cancel. They will cancel. Now both are in the same direction, cos component. So the net electric field, which is the vector sum, in vector sum this has been cancelled. Now this is in the same direction, so this would be E cos theta plus E cos theta. So this would be 2 E cos theta. This is the net electric field. Is this part clear to you?
Yes, sir.
So we already know that what is this E? What is this E? We already know from here that E net, or which is E equatorial, this is 2. E is K cube divided by H, which is root of and cos theta. Clear?
Yes, sir.
Okay, so now let us get back to the triangle again. So we have this thing. This is theta. This is base, which is A. This is base. This is R, which is perpendicular. This is hypotenuse. So what would be cos theta? Can you tell me? What would be cos theta? Yeah, what would be cos theta? Yes, what would be cos theta? You know trigonometric ratio, right? Trigonometric ratio. So what is cos theta? Cos theta is based upon hypotenuse, right?
Yes, sir.
So base upon hypotenuse. What is base? Base is A, hypotenuse is H. So this is A by H, right?
Yes, sir.
So this thing is there. So we will put this thing. We just remember this thing and we'll put all these values. So what is this thing? So this is 2K cube and cos theta is A, and this is A by H, and this is H square. Now we will put the value of H, right? So what is H? H is root of R square plus A square and then whole square. And then this A by H. H is again root of R square plus A square. So this is E equatorial, right?
Yes. Yes, sir.
Now you see that this is 2A and Q K divided by, I can write root of this thing as R square plus A square, right? And then this root cancels out, right? Because this is power half, this is square, so this cancels out. And this I can write it as R square plus A square power half, right?
Yes, sir.
So the base is same, power is different. So power will add up, and this would be K and 2A cube divided by R square plus A square, and then 1 plus half, so that is 3 by 2. So this would be K 2A cube and then divided by R square plus A square and then 3 by 2. So is this part clear to you?
Yes, sir.
Again, you see that because R is very much greater than A, so we can neglect this thing and it will become simply, right? So this would be 2A cube divided by R square, and this part is neglected. So this is 3 by 2, 2 and 2 cancels, and we will get equatorial electric field. This would be K 2A cube divided by R cube. Can you tell me what is this value? 2AQ is how much? What is this 2AQ? In dipole, what is this 2AQ? That is that thing we have discussed in the earlier part. So 2AQ we have discussed. What is 2AQ?
Thank you.
2AQ was this And what was this P? Charge into separation. What was this charge into separation? That was the dipole moment, right?
Yes, sir.
So this is the dipole moment, right? And did you not take the assessment? So did you go through that assessment that happens after the class? So did you go through that? Because I guess you
No.
did, yeah, you didn't attempt any assessment. So please try those assessments, right? That will help
Yes,
you
sir.
to figure out what concept you are understanding and what you are not able to understand. So please take those assessments, right?
Yes,
Okay,
sir.
so this 2aq is the dipole moment, right? And what is the dipole moment? That is the charge into separation. So that is the dipole moment. So now let us write 2aq. This is P. So P is dipole moment, and which is what? Which is charge into separation. Right. So this becomes EQ, and this is the magnitude of the electric field due to a dipole at the equatorial point. And you see that, can you tell me in this diagram, what is the direction of dipole moment? For this dipole AB, for this AB dipole, what is the direction of dipole moment? What is the direction of dipole moment? Do you remember what is the direction of dipole moment?
So, from negative to positive charge.
Absolutely correct. Yeah. So yeah, good. So negative to positive direction. So this dipole moment direction is in this direction, right? In this direction. So this is dipole moment, right? And you see that electric field is in the opposite direction, right? Electric field is in the opposite direction. So that will have minus P hat direction, right?
Yes, sir.
So this is P hat, this is minus P hat. So in the case of equatorial point, if I write it in vector notations, so this would be minus Kp divided by R. So this is the electric field of the dipole at the equatorial point. So please note it down. And if you have any ounce of doubt in this one, please tell me. So this is the electric field of the dipole at equatorial point. This diagram is important. If you understand this diagram, then rest of the calculation will become easy, right? So please note this thing down, and if you have any doubt, or if you want me to repeat this thing, then I will repeat this thing again, right? Because the derivation of electric dipole is very important. That will come in your exam. So if you have any confusion, any doubt, please tell me. Otherwise, please note it down. So please note it down, and whenever you want me to scroll down the screen, please.
Yes, sir.
Yeah, whenever you want me to scroll down, please tell me.
Yes.
Yeah, whenever you want me to scroll down, please tell me.
Okay. You can scroll down.
Hmm. And whatever derivations we have done so far in this chapter, please go through all of them, right? Because those are very important.
Yes.
Yeah, whenever you have noted it down, please take.
Yes. Done.
Yeah. So let us summarize this electric dipole, right? Let us summarize this electric dipole. What have we learned so far? So firstly, we have understood about electric fields, right? So a quick summary. So first we understood about the preliminary ideas of electric field. So electric field due to a point charge, right? Due to a point charge, we discussed, and this was what? So this was simply kq by r square, right? And then we discussed that what would be the electric field due to multiple charges. Due to multiple charges, this is simply E1 plus E2 plus E3 and so on. So this is because the electric field is a vector quantity. And then we started talking about the dipole. So we talked about this dipole, right? And firstly, we understood that what is this dipole. So dipole is a system of two charges which contains negative and positive charges, and then there is a separation between them, which is 2a. So this system is called dipole, and this dipole has a dipole moment. This is dipole moment, and this is simply the separation into the charge. So what is this separation? So in this case, the magnitude is what? And it goes from negative to positive. So this is the direction of the dipole moment. Right. And then this is charge, and then the separation is 2a. So we understood that for this system, the dipole is simply 2aq. Right. This is the dipole moment if we take the separation to be 2a. Why do we take 2a? Because this makes the calculation simpler. So we understood about this dipole. We understood what is the direction of this dipole. And then we were talking about the electric field. So we were talking about the electric field. And we were discussing that what is the electric field due to dipole at axial and equatorial point. So these are the two things we discussed, right? And to summarize this thing again, so for axial point, what did we discuss? And for equatorial point, what did we discuss? So at axial point, what was this thing? So we had this dipole, right? And the separation was 2a. We took half of the point, right? Midpoint of this thing. And then we wanted to calculate the electric field at this point. So we calculated this electric field. This was R, and it had two contribution. It had two contribution, one due to plus Q. This was E1, and then one due to minus Q. This was this thing. So this is the P point, E2. And then we calculated that E was E1 minus E2 because that is a vector sum. And we found out that this is 2kp by R3. Right, this is axial. So if we write it in vector notations, so electric field at the axial point, this was 2k p divided by R2. So this was the axial, right? So what was the takeaway of this derivation? So the takeaway was that electric field is in the same direction as dipole moment. Both have same direction. This is the first point. Second point is that electric field is varying as 1 over RQ. So this is varying like 1 over RQ. K is constant, P is constant, right? So this is varying as 1 over RQ. And so these are the 2 points, right? These are the 2 points. What do we understand about the equatorial point? Give me one moment.
Yes.
Give me one moment. So very important. Yeah, give me one moment. Yes, you got disconnected.
Okay, yes.
Yeah, so what we were discussing? We were discussing that we discussed what happens for the axial point, and then we were discussing for the equatorial point, right? So what happens for the equatorial point? So we have two charges. We have a dipole which contains two charges, and then this is the distance 2a. We take the distance from the middle point, and then we take a perpendicular bisector, and now we are measuring the electric field at this point. So we solved this thing, and what we got was that this was the overall electric field, and this was the overall electric field, right? We saw that sine theta component, sine theta and sine theta got cancelled, and cos theta got added. So these were added, and E net was 2E cos theta, right? And we solved this thing, and then we got that E equatorial was Kp by Rq. But if when we wrote this thing in the vector form, so this E equatorial was minus Kp by Rq. By minus, because this was in the opposite. So this is the dipole moment direction, and electric field is in this direction. So that is why we have this minus. So for this one, electric field is so electric field is against the direction of dipole moment. And then second point is that E is varying as 1 over RQ. Again, 1 over RQ. And the third point, if we compare this axial and equatorial, so magnitude of E axial is twice the magnitude of E equatorial. So we have E axial, this is 2 E equatorial. So this is the thing, this is the takeaway that we have discussed. So please note down this part. From this one, this is the summary, right? So if you don't remember this thing, if you don't remember the previous thing, then if you just look at these, then you will be able to remember. So just note down this thing, right? Quickly note down this thing, and then we'll do some questions, and then we'll talk about.
Yes.
Yeah, please note it down, and whenever you have noted this thing, please tell me.
Okay.
Yeah, just note it down, and if you have noted it down, just
Yes. Done, sir.
Done.
Yes, sir.
So let us do some questions, and then this would become easy to understand, right? So you have find the magnitude of the electric field due to dipole for the given figure, right? So this is the yes, this is the first question, and the figure is that we have this these two charges, right? And then the separation between them is let's say, so this is minus 2 microcoulomb. This is plus 2 microcoulomb. Separation between them is let's say 6, right? 6 millimeters. And then we want to find out the electric field at this point, this P point, and at this Q point. So this P point is, let's say, 20 meters away, 20 millimeters away. And this Q point is, let's say, this is 16 millimeters away, right? So 16 millimeters away. And this should be larger. So all these things would be larger, because then we can neglect this thing. But let's say that we take these numbers, right? These numbers should be large, but let's say that these numbers we take. So this point, this P point is axial point. This Q point is the equatorial point. Right.
Yes, sir.
So what would be the, we already know that what is the electric field. So we already know that electric field at axial point magnitude is 2 kp divided by RQ. And we also know that V equatorial is kp by RQ. So these things we already know. Right, value of K is 9 into 10 to the power 9. This thing we also know. So let us calculate, and P we know. P is how much? P is charge into separation. So what is that? Q is 2 microcoulomb and separation is 6 millimeters. Right. So
Yes.
P we also know, and R is also given. R is 20 millimeters for axial point, and for axial. And this is, let's say R is 16 millimeters for equatorial point. Right. So then if we calculate, if we put all these values in the formula, so what would be E axial? E axial is 2, K is 9 into 10 to the power 9. P is 2 into 10 to the power minus 6 coulomb, and then 6 millimeters is 10 to the power minus 3. and r cube. R is 20 into millimeter, that is 10 to the power minus 3, and then cube. So this is the electric field at the axial point, right? So what would be this thing? So this is 2 into 9 into 2 into 6, and then this is 10 to the power 9 minus 6 minus 3 divided by, this is how much? So this is 20 into 10 to the power minus 3. So this would be 2 into 10 to the power minus 2. So this is 2 into 2 into 2, and then this is 10 to the power minus 9, right? So
Yes, sir.
this would be how much, right? So this is this 2 and this 2 will cancel, this 2 and this 2 will cancel, and this is 3. So this is 27, and then 10 to the power, this 6 minus 3 is 9. So 9 and 9 cancels, and this plus 9 goes over there. So 9 minus 6 minus 3 plus 9. So 3 and 6 cancels 1, 9. So this is 27 into 10 to the power 9, right? And this is what? So this is E is F by Q. So that is Newton per coulomb, right? This would be E axial. And what would be E equatorial? So E equatorial, this is again what is the dipole moment? That is Kp by Rq. So K is 2 into 9 into 10 to the power, yeah, this 2 is not there. So this is 9 into 10 to the power 9. P is 2 into 10 to the power minus 6, and 6 into 10 to the power minus 3. R cube is 16 into 10 to the power minus 3, right? And then cube. So this is how much? This is 9 into 2 into 6, and then this is 10, 9 minus 9 divided by, this is 16 into 16 into 16, and then this is 10 to the power minus 9. So this minus 9 and this 9 cancels, and what do we have? So this is 2, 8, and then this is 3, and then this is 8. So 27 by this much, 64 into 16, and into 10 to the power 9. So whatever this value is, right? So how much is this? 27 divided by 64 divided by 16. So this is 0.026 into 10 to the power 9 Newton per coulomb. So this would be 2.6 into 10 to the power 7 Newton per coulomb. So this is E equatorial. Clear?
Yes, sir.
Yeah, so please note down all these. Please note down this question.
Okay, sir.
And if you have any doubt, please tell me. So this is just direct the formula. This is, you have to just put the formula, right?
Yes, sir.
Yeah, whenever you want me to scroll down the screen, please tell.
Yes.
Yeah, whenever you have noted it down, please tell.
You can scroll down.
Yeah. Yeah, whenever you have noted, please tell.
Yes. Done, sir.
Yeah. Okay. So now let us do another question, and then we'll talk about the next topic. So let's do one more question. So two charges let's say uh, minus 6 microcoulomb, or let me write minus 4 microcoulomb and plus 4 microcoulomb are placed at let's say, so this one is minus 3 comma 0 comma 0 millimeters and 3 comma 0 comma 0 millimeters, right? Find
Yes.
the electric field at let's say, let me write it as yeah. So let me write it as 0 and 4 and 0 meters. So this is in meters, and then and this is let's say this is 400 meters, right? So these are the two positions that I want to calculate the electric field. So these are the two positions, and you are only given all these things. So did you understand the question?
Yes.
Okay, so if you have understood the question, please find out the electric field at this position. So let's say this is one part and this is second part. So
Okay.
please try this one. Please try this one.
Okay.
Yeah, so please try this question. Whenever you get the answer, please tell.
Yes.
You just draw the coordinates, you just draw the diagram, and then it will become easy to.
Okay.
Yeah, whenever you get the answer, please tell me.
Yes.
Yes, did you get any answer?
No, sir, not yet, sir.
Yeah, please try this one and
Yes, sir.
yes, did you get stuck?
Yeah, I guess so, sir. Um, I'm not really getting the answer.
Okay, so yeah, so let me just do that thing and give me one now. So, yeah, give me one.
Yes.
Okay. So now Yeah. So if we draw the diagram, right? If we draw the diagram, then what would be the diagram? So let's say we have this, because you see that z-axis is 0. Z part is always 0. So we'll just draw the x and y-axis. Right? So this is x, this is y. And yeah, give me, yes, give me 1 moment.
Okay.
Okay, so this is 1 point is minus 3 comma 0. So where is this? This is this one. And remember, this is in millimeters. So this is minus 3 comma 0. This is your minus 4 Coulomb charge. And then we have 3 comma 0. So this is at this position. 3 comma 0. And this is plus 4 micro Coulomb charge. So what is this thing? Can you tell me what is this thing? This system. What is this system? This system is a dipole, right? You have two charges equal magnitude, so this system is a dipole, right?
Yes, sir.
And now you want to calculate, so now you want to calculate the electric field at 0 comma 4. 0 comma 4 is y-axis, right? 0 means x is 0 comma 4. So let's say at this point. So in here you want to calculate. This is 0 comma 4. And this is in meters. This is in millimeters. So we have to be very careful. So at this point, we want to calculate the electric field. What is this point? Axial or equatorial? What is this point? So what is this point? Axial or equatorial? This point. This A point is axial or equatorial?
Say equatorial.
Equatorial, right? So this is equatorial. So you want to calculate the equatorial one. We know that that is Kp by Rq. So K is 9 into 10 to the power 9. P is charge into separation. Charge is 4 microcoulomb. Separation is how much? 6 millimeters. And divided by R. R is 4 meters. So this would be how much? This is 9 into 10 to the power 9. 4 micro is 10 to the power minus 6. And then this is 6. Milli is 10 to the power minus 3. And then this is in meters. So this we can write as this thing, right? So 4 and 4 cancels. This is 3 and this is 2. And then this becomes what? So this is simply 9 2s are 27 by 8. And then 9 minus 9, that is 10 to the power 0. 10 to the power 0 is 1. So this would be 1. So this is simply 27 by 8 Newton per coulomb. Is this point clear?
Yes, sir.
And then second one is axial. Second one is axial. What is that? That is 2 kp by r. So this would be 2 into 9 into 10 to the power 9. And this is 4 microcoulomb, then 6 millimeters, and then RQ. So that is 4Q. So all these values are same because we want to calculate the electric field at this 4 comma 0 meters. So this point is, let's say this B point is axial point. This is the second case, right? This point is the second case.
Yes, sir.
So this would be how much? This would be 9, 2 into 9 into 10 to the power 9. 4 microcoulomb is minus 6. 6 is 10 to the power minus 3. And then 4 into 4 into 4. So 4 and 4 cancels. This is 3. This is 2. And then this and 2 and this 2 cancels. So this is And then 6 minus 3 is 9, 9 minus 9 is 0. So you have only 9 is at 27 divided by 4. So this is the answer. Is it clear?
Yes, sir.
So this is where did you get stuck? Where did you get stuck?
So from the graph that I couldn't draw.
Oh,
maybe
this one.
Yes,
Yeah, so just remember that A point is the equatorial point and B point is the axial one. So case first is equatorial, case second is that. This was the change. Just note it down and then we'll do the next. Then we'll talk about the other part, right?
Okay, sir.
Yeah, whenever you want me to scroll down, please tell me.
Okay.
Yeah, whenever you want me to scroll down the screen, please tell.
Yes, sir. You can scroll down.
Whenever you have noted, please tell.
Okay, done, sir.
Okay, so now let us understand the other topic, which is, so now we have understood, right? We have understood that what is, so we have understood that what is the Coulomb's law, right?
Yes, sir.
We have understood what is the Coulomb's law, that if we have two charges, right, Q1 and Q2, separation between them is R, so force is simply K Q1 Q2 by R square. And we have also seen that what is equilibrium? So equilibrium is simply your F net becomes 0, right? And we saw two kinds of equilibrium, one point equilibrium and then system equilibrium. So these two things we have discussed. And then we have also saw some tension question, right?
Yes, sir.
Equilibrium with tension. And then we have talked about the superposition principle of force. And we saw that force is simply the vector sum of individual forces, right? This thing we saw. And then we saw that, we saw that what is the Coulomb's law? Coulomb's law in vector form. And what was that? So F12 was simply K R1 minus R2 divided by R1 minus R2 mod and then Q. Right? And this is Q1, Q2. So this was the Coulomb force in vector form, right?
Yes, sir.
And then we talked about electric fields. So then we talked about electric fields. So this much we have done. Right. This much we
Yes,
have done. The next topic is, so you please revise all these portions along with their questions. And the next thing that we have to discuss is force on charged particle. In external electric field. Right, so we want to calculate what is the force on charged particle in external electric field. So let us try to find it. So let's say we have some electric field which is varying like this. So this is some electric field. We will talk about electric field lines in a moment, and then you will see that why I'm drawing this thing. So this is, yeah. So do you want to have some water, or do you want to take some 5 minute break, right? Because
Yes, sir.
yeah, if it is okay, then yeah, if you want to have some water, then you can go and then have some water, or if you want to continue, then you can continue, right?
So, can I pray and come?
Pray will take, so this is Isha Namaz, right? Isha Namaz will take 15 to 20 minutes, right?
So, because before our class ends, the next salah's it will start. So,
So yours would be Maghrib one.
so my Maghrib's, it's the time is already finished, I guess. Like in before 8, uh, the Isha's Adhan will be there.
Okay. Yeah, so yeah, you want to go for which prayer? Maghrib or
Maghrib.
Isha? Maghrib.
Yes, sir.
Oh, so that will take 5 minutes, right? So yeah, you can just go and then quickly return, right?
Yes. Okay, sir. Thank you.
Yeah, yes, I will wait for 5 minutes, right? Please go and pray for me also, right?
Okay. I'm back.
Yes, yes, good. So yeah, again, you will have an assessment. So please take that, and the assessment would be on this electric dipole. So electric field due to a dipole. That would be the assessment, right? So please take that after this class ends. So yeah, please log into the Learnivio account, and then you'll find some assessment. Okay. Yeah, and please, so your exam will happen on 4th June, right? Did you get the syllabus of that exam? Did you get that?
Yes.
Oh, so how many chapters are coming in the exam?
So I'm pretty sure there's only.
Yes,
I think only vectors.
only vectors.
Yes, sir.
So vector is not a chapter, right? Only electric charges and fields. That is the chapter. So your teacher is doing in your school, yeah, in your school, your teacher is doing vectors.
No, sir. Oh, I thought. So you're talking about the Learnivio's exam,
No,
right? I
no,
mean the
no,
test.
no, 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 not that one, not that one. I'm talking about the school one. So in your
For the
school,
school one, they haven't announced yet, sir. I think they will announce it by next week.
oh yeah, because yeah, so that is what, because we can speed our classes, right, according to that. So what should be the pace of the class? We can decide when we have the syllabus. If they are asking 2 chapters, then we have to increase the speed. If they are asking only 1 chapter, then that is fine. So we are almost ending this chapter, right? So
Yes,
yeah.
sir.
And today is only the 2nd of May. So I guess they will give 2 chapters, right? But let's see
Yes.
how much they give. And if they give only 1 chapter, then we can revise this chapter many a times, right? So then we can do that.
Yes.
Okay, so what is the topic is what is the force on charged particle? So in external electric field, right? We have only talked about the force between 2 charges. So now in this case, you don't have 2 charges. You have an electric field, and then in that electric field, you have some charge which is there. So then what would be the force experienced by that charge particle? So one case is positive charge. So for positive charge, if this is the electric field is going in the right hand direction, and you put some charge in here. This is Q charge plus Q charge. So then this charge will experience some force, and that force would be equal to, this force would be equal to QE, and this would be in the same direction as electric field.
Yes.
So this would be the force. The force would be in this direction, same as electric field. So force will be in the same direction as electric field, and it will be QE. So this would be the force. If we have a negative charge, so if we have a negative charge, right? Then what would be the force experienced by that negative charge? So what would be that? So we have this electric field, right? And this is electric field, and some negative charge is placed. So some negative charge is placed. So for negative charge, the electric field. So for negative charge, the force would be in the opposite direction. This would be force which would be minus QE. Right. So for this case, force will be in the opposite direction as electric field, and it will be minus QE. So this is the force on charged particle in the presence of electric field. So please note down this thing, and then we will do 2 questions on this one. So we'll do 2 questions.
Yes.
Yeah, whenever you have noted, please tell me.
Yes. Done.
Done. Okay, so let us do one question. Right. Let us do one question. So let's say that okay, let me check what is that question. So I don't remember that question, but let me check that. So what is that question? Yeah, so the question is, these are, okay, so these are the question. Yeah, so okay, so what is the question? That you have some electric field, right? You have some electric field which is in this direction. Right. This is
Yes.
the electric field. And now some charge is put in this electric field. This is some, let's say this is some proton, or let's say this is some Q charge, which is put in this electric field. And this is not because, if there is no electric field. If there is no electric field and you put this charge in here, so what will happen to this charge? This is the ground. If you put this charge in here, so what will happen to this charge? This has some mass. This charge has some mass. So what will happen to this charge? If you put this charge in the air, it will drop down, right? It will drop down.
Yes.
And why it will drop down? Because of the gravitational force. Gravitational force. And what is the gravitational force? This is mg. So due to gravitational force, it will drop down. Right. Now, in
Yes,
this case, you have the electric field. Electric field which is in this direction. And now you put this charge in here and you have to find the electric field so that charge remains in the air. Right, so did you understand the question? So this thing is not dropping down. Right, this thing is not dropping down. Why? Because we have two forces. One is this one is this one. One is the gravitational force. Right, this charge has mass m, so this has gravitational force, and due to this electric field, this would have some electric force. Right.
yes,
So you see that this electric force, so the answer is that the electric force is balancing the gravitational force. Right. So the electric force is balancing the gravitational force. So this will keep the charge stationary. So your electric force, this is equal to the gravitational force, right? Fe is electric force. Fg is gravitational force.
yes, sir.
So Fe is how much? This is QE, we have just learned. And Fg is how much? That is mg. So this electric field would be mg by q. So this much amount of electric field we require so that this is balanced. So this charge will not move. It will not drop down. If we don't have any electric field, so it will drop down. Right? It will. If you put some pen in the air and then you remove on your hand, so then it will drop down due to the gravitational acceleration. But this charge is stationary. This is not dropping down because you have this electric field which is in upward direction. So yeah, if this thing is this thing clear to you? Is this question clear?
Yes, sir.
Okay, then please note it down and then we'll stop. So please note it down.
Okay, sir.